All right. All right. So as Julie introduced me, my name is Jonathan Fite. I work for EverDriven, which is a nationwide student transportation company. I am the senior database administrator for that company. And 3 years ago, they came to us, and I think around September, and said, we're going to move our entire infrastructure into Azure. You've got 2 months to do it. And this met most of us with a lot of grief. The reason behind the deadline was because we do transport students, we're tied to the calendar year, to the school year mostly. So Christmas, or that break, was the ideal time for us to move with the least disruption to servicing our customers. So that's why they chose that. Fortunately, with that announcement, they also opened up the pocketbook. And because the critical thing was iterating. We did a lot of move to the cloud during that 2-month lead up to that time frame. So we did a lot. No. When they said do it, and they said we are going to practice doing this the whole 2-month period. I think I deployed to the cloud 4 or 6 times, various systems, sometimes all at once, sometimes system at a time, practice, work out the kinks, get really smooth. So your timelines, basically. How long does this take? What can go wrong? When it goes wrong, how do I resolve it? So this was our migrating to Azure. And from one perspective, Azure is very cool. It is the modern thing. You're basically getting away from hardware maintenance at all, or in some cases, maintaining your operating systems. You don't have that anymore with, for example, managed instances or anything as a service. So our on-prem environment wasn't this bad, but this is what we moved from. So our on-prem environment, this is what we had. So I moved, we had a single flagship database, approximately 1 terabyte in size. This was where everything lived and worked. We had 5,000 mobile devices pumping their GPS coordinates into this database every 50 seconds. We had 10,000 passengers being serviced every day throughout this system, servicing various reports and updates and all this fun stuff. That was our flagship database. We had various support databases, as one does. You build up ancillary systems to help other systems. And then we had some legacy databases, which are, as with any environment, these are the databases that the users created. And then when the person who implemented it or developed it moved on, it got passed into IT suddenly saying, by the way, this is mission critical. And we're like, great, thank you so much. We had various business intelligence systems in place that had to be migrated. The BI stuff, at least from the beginning, our continuity plan for the BI stuff was this is a shell. We will rebuild from the source systems. And so that's what we did. All I had to do was deploy a shell and then run the migration scripts to bring them across. And then we had various services running around, reporting services, analysis, integration type of a thing. CRM, which thankfully is gone. Several years later, it went away. But we had a CRM system. This one was our bugaboo. As you can see the specs on that, 2005 and Windows 2000. So the only way to move that guy along was to build a VM. Actually, we'll go to the next slide where we talk about what we chose for each one and why. So we started off with what features is each of these databases using, and that controlled pretty much where they could live. If you want to have agent jobs, link servers, and triggers, well, triggers that talk to other systems, which is what we had in our flagship database, then you are going to want to use a managed instance as your lowest level. You could, of course, do everything in a VM. There's nothing wrong with that, except that you're still managing an operating system. And do you really want to be doing that? And then some things we're able to get into an Azure SQL database. So we have an Azure SQL DB floating around with a couple of databases on it. And these were very simple databases or simple applications, really just a table, a couple of tables, and some insert, some CRUD activity. And then we have some that are VMs, integration services, because we did not want to migrate to the Power Factory. We have a reporting server because we're tied to using reporting services for a lot of our stuff. And then, of course, we have analysis services as well. And then the CRM machine. I'll talk more about the CRM machine, what we ended up having to doing.
How long did it take you to spin your managed instances up? I was seeing 8 hours.
8 hours is fast. At the time we were doing this, I think managed instances had just recently, within the prior 6 months or so, hit public release or general availability, especially in our region. And so we were looking at longer than that for a lot of times, spinning those up. And then if you're wanting to spin up a failover group, which is what we ended up doing for high availability, you took twice as long. You had to spin up one, then you had to spin up its partner. And you could work on the primary while the secondary was coming up, but you weren't going to be fully synchronized until it came up and then the data. I'll talk about in detail more about that because we did that. It was a trial for us. Oh yeah, and like I said, they had to open their pocketbooks for this because even if you have like the credits for like a Visual Studio, license and whatever, by the time it's finished spinning up, you've burned through all of your credits because they're expensive. They're expensive. So on sticker shock here, managed instances especially are expensive. The guy who does the budget for this stuff just glares at me now, and I'm like, well, I've told you, if you gave me a couple of say a year's worth of the managed instance spend on this, I can build me a cluster of 6 really high performance machines, and I can build something that won't cost you any recurring costs except electricity for a while. But you get a lot of benefits. The business really likes the benefits of having this as a service, as an ongoing capital expense rather than an investment. They just really like that, which is fine. I have no problems. Whatever you want to spend money on. My job is to tell them how much it will cost to achieve objectives, not make the decisions about whether it's too much money. So during the migration, we realized that we had implemented some in-memory optimized tables, and those had to go away because the business critical, which is the only way you get managed in-memory optimized objects for managed instances, was about 50% more expensive to get the higher grade of managed instance. We had to change some other things. We had the way we were doing some log extraction and analysis was originally just insert into a link server using 4-part names, and that worked in on-prem, but does not work in the cloud with Azure SQL database as the target for your link server. You can update, you can definitely insert data into those servers using 4-part names, but you can't insert into 4-part name table these values in this construct. Just didn't work for us. So we used an SSIS to pull the data up and then go around. It worked. And then we had to change the garbage collector method we had from using back to the old method because we had moved to a faster method using snapshots. We couldn't do that anymore. So we had to go back to using the old method. So it was just a couple of minor things, some feature completeness, and we just decided to make those changes. And they again discovered during that 2-month lead up, because again, iterate over your migration. You have to do it so that when the day of happens, you are ready to go and you know what's going to fail, what's not going to fail, what you need to change. All right. So this was our iteration. Like I said, we did this probably 4 or 6 times over that 2-month time frame. Was really helpful. Learned a lot of things, like our outgoing network would periodically drop on us and resume, which is fine during the day, but when you're trying to move terabytes of data and then that process dies in the middle and can't resume, that is a problem. You'd start over and you're like, oh, I know we were planning to migrate this Saturday, but 12 hours in, it died, so we have to start over, and now it's going to be Sunday that we do the migration. You know, outgoing network from data center. Also had to make sure I used the correct data center. It was faster for me to sometimes shove stuff from our secondary site out, because that was the site that had the large pipe to Azure. Our large pipe to Azure. They actually increased the size of our network connection, our internet connection, to accommodate this transfer. No, didn't really look into it.
I have 13 terabytes of data point to move, so I ended up, because it would have taken me 2 months to get that much out of my data center.
Yeah, it takes a while. It takes a while, and you can get. I know you can buy. And forgive me, I'm not a network guy. I know you can buy direct connections into Azure, which will get you from your office to Azure data center, and you can get a really fast pipe that way. And if you're doing any type of hybrid with Azure, it would definitely be something I would consider looking into, so you can move data fast enough for that. So the way we got data out of our environment, we used AZ copy, which is a utility you can use to copy from file shares local to storage accounts. I used AZ copy because you could set number of threads, you could set retries, you could save the journal files, so it could have resumable copies. So if it died in the middle of a transfer, you could resume it from where it left off instead of having to start over from scratch. So that was great. I used BCP to extract some of our smaller databases. This was rather than trying to do, oh goodness, I've forgotten the name of the technology, database archives. Because we were going into SQL, Azure SQL, SQL DB, and we couldn't do restores into that environment. So we did, instead of a DAC, we did BCP. Other environments just supported backups and restores. And at the time, all we could use was database migration services to do log files, basically, from your source system into a managed instance. You could always, and still today, can do a full backup as a restore from a storage account. Load your file into the storage account, attach the storage account to the managed instance, and then you can restore the full backup. You cannot do anything else. You can't do the differentials, you can't do the logs, because as soon as you finish that restore, it automatically does with recovery at the end of it. So you're not allowed to keep it open and just keep tacking on more. There is a new feature called log replay services, which is sort of like a lighter version of database migration services. I have not used it. I think it hit general availability earlier this year. And it will let you put all of your files into a storage account and replay, or basically restore the full and the differential, and then continuously restore the log files onto it. And then when you're ready, you can say, I'm done, now bring with recovery. It's meant purely for migrations. It's not suitable for doing any type of log shipping. The database is not available while it's being there, and the source system has to be like an on-prem or an array of third-party clouds, Amazon, Google, that sort of thing, cloud providers. So database migration services is what we used. If I were to do it again, I would definitely do log replay services, or at least try it. I talk, and then a couple of slides about database migration services and how I had to work around some of its issues. So fun. Like I said, iterate over this, do this over and over again, so you know what's going to happen. The requirements for me, of course, low impact. I could not impact our production system or as much as possible. We wanted to stay online. The initial requirement was to stay online during the migration and have a small hour-long window of cutover. So I think I put here managed instances took about 6 or more hours to provision. So rebuilding it from scratch was not ideal. Ideally, we would have systems build all these environments for us, and then we would start the restore process. I had network hiccups. I had capped upload speeds. I hit the 5 terabytes per storage account that Azure imposed. So I had to break into my storage accounts into multiple pieces so that I could contain all of my data. It was fun. It was fun. So I think here we had AZ copying files from our local environment up into storage accounts automatically for me. There's a couple of options in there. You can use the journal location, of course. You can back up and restore from URL in the managed instances. And we use BCP. I forgot during my migration to preserve the identity values. So that was a fun find on the restore when we brought it back up and we were online, and they were like, all the IDs are wrong. I was like, oh. Fortunately, the old system was still online, and it was a small database. We worked through it. We got through it. But who's testing all this stuff anyways? It wasn't supposed to all be me. Somebody was supposed to tell me that. What was the yeah. So our first rollover, we sent the backups to the local file share, and then we use database migration services, which has a feature. It's great. You configure it, and you have it reach into your local network to wherever you have these backup files being generated, and it will pull them up to the cloud for you, and then do the continuous restore onto your managed instance. And this is great in theory. In practice, the transfer was single-threaded and slow. So copying my database out there would have taken days, is what I calculated it at. That's just my initial full backup. And at this point, I'm like, it's faster. That's not fast enough. Even if it worked, it's going to be like, I'm going to be days behind now. Now you're going to get all my differentials, and then I can't take any new full backups because that starts my chain over again during this time frame. It was a problem. Yeah, it was the slowest. Also, database migration services wanted to go back and talk to your source SQL Server and get the headers for the database backup files. You can catch that because it was, again, slow. But you can see that that's what it was doing, was trying to read the headers. And I was like, why do you need my server to read the headers of these backup files? Use something internal to you guys, or this nice shiny managed instance that I have, have it read the backup headers if you need to. So that was also slow because of course that file has to now come back to your local to read it. So that was fun. We had network hiccups, which interrupted the copies, and database migration services in general. It hit a hiccup and it would fail, and there's no resume. You was like, okay, destroy your database migration services instance that you've created, spin up a new one, reconfigure everything, and hope that this time it will complete. I think I had maybe one successful with this before we were like, we have to do something else. At the time, their forums were full of people complaining about all of this, of course. So I built a workaround, and I don't know if anybody else came up with this workaround for it, but I was able to get it to going. So broke it up into several pieces. I used AZ copy to get my backups from my local to a storage account. This was much faster. AZ copy could go multi-threaded and was resumable. I stood up a virtual machine running SQL Express in the cloud. And then I told Database Migration Services that that SQL Express machine was that's my source machine. And it would use it to read the headers. That's all it wanted to do it for. Like I said, it's stupid that it needed this machine. But so I stood up a SQL Express instance just to read headers for Database Migration Services because that's what it wanted. And then it internally would copy files around all over the place again. So I would send them to a storage account. Database Migration Services would read from that storage account, which I told was actually a URL, a file share, copy it to its own blob storage that it needed, use my Express machine to read the headers, and then it would restore those onto my managed instance. You know, the great thing about this, though, is that since it was all in the cloud as far as migration services was concerned, it worked. I think I still had things where it would just fall over on its own head, but none of it was network hiccups. And so this was successful. We did have one of our migration attempts where it just didn't complete. We hit the I'm ready to finalize my migration, bring my database up, and it never did it, never finished. And so you're like, okay, so I guess I have to start over now of my restore and my replay of the logs and all that fun stuff. And that's what I did. It went a lot faster because I was in the cloud, so I was able to copy files. It was able to copy files at like 500 gigs. So, but still, I was doing this a lot. Mm-hmm. That's exactly what you're hoping. Yeah. So this is all because this all gets fed back up to the guy, to our head guy, trying to plan and organize the whole effort, right? Because we eventually decide that we are not going to do this. Our final migration plan was we were going to stop the company at, I think, Friday at 7 p.m. Stop. And then that was when, and of course, systems had all the targets built. The environment was built in Azure ahead of time. But that was when we stopped. I took a full backup, copied it to the cloud, which I knew exactly how long that took, and then restored into there. So a single backup file, and none of this shenanigans with database migration services or log replay or worrying about all of this. Because to your point, it's like we could get there and it not do anything, and I have to start over. And then like, okay, now everybody who was counting on this database being up at this time, I need another 12 hours.
Your original window was a 1 hour outage?
That was the plan. Because we were going to do log replay, right? So the business would be up, and basically on that last log, we'd stop the business, make that last log get all the way up in there, replay, and there's our data. Database is ready to go. But they went with, I think, the much smarter approach. They took a longer outage. Basically, we had the whole weekend. We did not need the whole weekend, but we had the entire weekend as, again, lower risk because we were tied to the school year. Next week, we were starting trips were restarting, and we were going to be transporting thousands of students again. And they did not want to run the business on paper, which in theory, they're supposed to be able to, but you know, I don't think anybody's ever tested that. Oh yeah, this is just my end. This is all my end. On the other side, the application team is standing up Service Fabric nodes and building all of the stuff that they need to run the app, or building up VDI machines so people can remote in. And this whole huge infrastructure is also going on in place around me. But the database is where real data lives. So this is where I was focused. There's a lot more going on, and we are 100% in the cloud. We do not have any on-prem machines or servers anywhere. We do have on-prem clients, of course, but no servers running anywhere. So you can't be in the cloud without high availability. And they are going to sell you on the fact that when you provision a machine or a service, that it's already redundant locally in that data center. In theory, you provision a managed instance, and you've actually got you've reserved three compute nodes for that, and redundant data all locally. So that if that rack goes down, you're still up. You know, and this works great. except when data centers fall apart, or networks to data centers, or as I talk about later, you get stuck in a software update bug, which is fun. So you need to have a more robust high availability than that. And for us, we chose failover groups for our managed instances, which means we have one node running in US Central and another node running in US East. And you choose these, of course, based on paired data centers. All right, so US Central's pair is US East, and they have a faster pipe, dedicated pipe between those paired data centers. You're also not supposed to pay for data egress because you're using a paired data center versus a non-paired. If you went to a non-paired data center, you would be paying data egress charges for that. So there's some behind the scenes decisions about why you choose which data centers to go with. So we did that for our Azure SQL databases as well. We use failover groups. For our infrastructure as a service, we're using the site recovery model, which keeps the disks replicated, and then they just basically clone the machine and fire it up on the other side. And then, as is always important, test your failovers. We are supposed to fail over our environments every 6 weeks. We haven't done it in quite a while because there's something quote unquote wrong with our US Central environment. It's not quite right. Something with the service fabric nodes, and they're working on it. But for several years, we were failing back and forth. And whenever we would have an issue, which I'm going to talk about, we would fail over, and that would usually resolve it. I've done it as well. It's painful. It's painful. You got to set up so many pieces. That's a whole thing. It's our internal. We're basically going to tear that down in pieces. We don't want to disturb up some pieces that are working, but our systems team is supposed to be tearing that down and rebuilding it. I think they're done. They're just a little gun shy about failing over. Did I lose my projector?
Another failover.
Yeah, it's just not. I'm going to disconnect that. I think I jostled a cable, maybe.
Local.
Yeah,
I would say we'll still see it.
yeah, because I'm sharing the screen. No, it should be HDMI, right? Did I jostle? There's no buttons here to push. No.
Is it still showing up online?
I see his screensaver.
Just my screensaver. Oh. Well, window P. All right, let's try this. That's still connected. Got a color. There. Okay. Now we try. We're gonna end that. Shift 5. Awesome. Are we sharing Excellent. Okay. Sorry for that brief interruption there. I touched a wire. We'll try not to do that. There we go. The other advantage of using rolling data centers is that they don't share, they're on different upgrade schedules. So USC will always be a different version, slightly different version than US East, so that if there is an issue, you can fail into the other node for that. All right. So some caveats there, of course, for failover groups, SQL DB must be in the same performance tier that bit us when we were trying to set it up. We were trying to have like primary be 1, and then the other one was not the same. The error message is not clear. That's what's wrong, but it does need to be the same. And then the SQL MI, you have to stand up the secondary instance with the intention of it being paired with the first one. So you have to build your primary, and then when you build your secondary, you're building it saying you are going to be a failover group of this guy over here. And then it stands it all up. Don't rush this process. I have queries included with my deck here that I developed that, because while failover groups look a lot like availability groups, they aren't. They use different DMVs to expose the transactional latency, all of the share status, the seed status, all of the stuff is different there. I think it took us 24 hours for the initial seed of our database. So once you restored your 1 terabyte database onto your primary side, it took 24 hours before the secondary had it. Ever after that, I've never caught it being more than a few LSNs behind primary. So it's a very fast asynchronous commit between those operations. All right, so here's our day of, which I already talked about. So this weekend of the fail, we gave a whole weekend. We failed over. They needed another database. They're like, oh yeah, bring this one over as well. Then we had some legacy performance issues, and then we had CRM performance, so the CRM machine, because it is so old. So the usual method, if you have a virtual machine running SQL Server, is you're going to use storage spaces to attach multiple disks, stripe them, and then you can get some decent I/O performance out of relatively cheap disks. That's your usual method. I suggest at least 4 if you're doing a virtual machine running SQL Server. Again, if you're using regular disks, you pay for the storage you use, not that you request. So you can request as big a disk as you want, as long as you don't use anything more than you only pay for what you use. But if you attach 4 disks, you can get up to something like is it 2,500 IOs? I think it's 500 IOPS per disk that you attach, and then it grows linearly as you add up to 4 disks. You can get up to 2,500 IOPS. Which is what you need. 500, it's going to suffer. But that Windows 2000 box doesn't have storage spaces, which means you can't do the striping method. So we had to end up paying for ultra SSD performance, ultra SSDs for that machine to get the I/O performance that we needed. Performance, like I said, that was a whole thing. SQL 2005 and even Windows 2000. Windows 2000 didn't understand the file shares or how to attach to an Azure storage spaces. I think it was the TLS version, mandatory TLS in Azure. It was, I think, 3 or, but anyways, Windows 2000 didn't go that high. We ended up using AZ copy running locally inside that machine to be able to transfer the backups out of it, to get it out of that machine and into the cloud somewhere so that I had backups for that machine. So there was a lot of shoehorning and struggling with just the ancientness of this machine, but we got it to work. They'll tell you it can run, but it's going to run terribly because it can't do any of the cool stuff to get decent performance. So we had to pay a lot of money for that CRM box, but fortunately we're off of it. It's gone. It's shut down. It's sitting idle somewhere waiting for somebody to need something out of it and pray that it comes up. But a lot of these issues, like the BCP, we had a legacy application issue that it was hashing the passwords and storing the hash in the database. But the hash algorithm changed when we got to the cloud. It was hashing in the database, and we got different answers for the same hash operation. So as one does. So the user would log in, and the system would send the password in clear text to the database. I love that. Database would hash that and then compare it to the value in the users table, and then say these aren't the same. So we had to go through and change everybody's password in the system because they couldn't quickly enough figure out how to redo that in the application. But again, somebody should have logged into this thing. They shot themselves in the foot on that one, I think. But that's a type of just random, who thought of this? Who didn't think of this issue? You know, I wouldn't have thought that the hash would change, hash algorithm would change between these engines, but it did.
Would you have that secure password seed problem across every on your database?
That was the only one doing password like that. Because again, it was sending clear text to the database, asking the database to hash it, and then it would, yeah. So you wouldn't ask. The right way to do it is to hash in the app and then compare those hash values to the database, and not the other way around. They send in clear text. Anyways, terrible. As I've learned with the cloud, it all comes down to I/O. In fact, in my performance tuning of queries, I focus very strongly on logical page reads for query tuning. Getting that number down almost always leads to a faster query, and it definitely leads to a query that makes less memory and requires fewer trips to the disk. So this is where I'm getting my performance, is making sure that I'm living within my I/O limitations. So as I mentioned, if you're in a VM, stripe your disks. It's the only way you're going to get adequate performance out of it, unless you really want to pay for Ultra SSD, which you probably shouldn't need to pay for that. If you're in Azure SQL DB, you're going to have to check your instance. You can use that the system view that I mentioned there to see whether you're approaching which limitation, DTU, and it'll tell you if you're approaching disk IO part of that, or CPU, and then you need to scale as appropriate with that. And those are your options with SQL DB.
So, since you started 3 years ago, I guess you had to go with DTU then? Do you have any vCores?
We are on vCores now, and we just bumped up to 6 because we were on 4 for a long time, but we had we finally started putting more stuff on there, and they just kept fighting each other, and then eventually one of them would stall out to have a job that just ran forever. So we gave it more DTUs. And that's the hard part with Azure, with SQL DB, is that when you exceed a DTU limit, you don't actually get an error in the application. You don't get a failure. You get, this operation took 5 times as long as it should have to complete, because it just stacked the IO request and then got to it as it got to it. So you have to watch for things getting slow suddenly to know that there's a problem there. Managed instances, we'll talk about that next slide. Another thing to worry about is cross-environment restores, going from prod to UAT to development, getting databases down all of those environments, especially if you implement transparent database encryption, which we have implemented TDE in our environment, which means we let Microsoft manage all the key rotations, which means now that it prohibits you from doing backups, taking explicit backups of your databases. You can only do backups and restore, or you're going to do restores from within Azure's commands limitations, which means getting from production to a lower environment became a challenge. One of the caveats with using that is you can do a cross restore like that as long as it's in the same subscription and the same data center. If those 2 requirements are met, then you can do a restore from your production environment with TDE into your UAT environment with TDE. Due to poor planning, our development environment is in a third data center to the others. And remember, we fail over, so I can only do restores into the UAT environment every 6 weeks. I usually tell the developers, like, when we fail into it and when we're about to fail out of it, I'm like, do you need me to refresh your environment? Because you're about to lose the ability for that. And you have to use PowerShell commands to do that restore. You can't do it in the UI at all. The reasoning for that is something about user authentication. According to the Microsoft engineer I talked to about it, it's user authentication, be able to restore your user credentials as your permissions to do the restore and the backup through all three pieces. And that's why you can't cross subscriptions, even though you're in the same, even the same account can do all the operations. You're crossing subscription barriers, so you can't do it. So that's it. Otherwise, you'll have to do another method for getting data out of your production environment and into your lowers if you're doing your stores like that. Just something to keep in mind. Fun. We didn't turn on TDE when we first moved to the cloud. We kept it open, which means I could do off-cycle backups to an Azure storage account and then restore wherever I could get that backup to. Database mail is also tricky. If you're going to use it on a managed instance, it has to be named very specifically. If you look in the setup for setting up database mail, it tells you the database mail must be named, I don't know, I can't remember, it's some garbage. The profile has to be named very specifically for it to work. You have to use certain ports now. We have ours hooked up through SendGrid, and it works. So we got database mail out of managed instances. Yes. You got to use 587 or something else. You got to use multi-factor authentication. It's a fun thing. One of the big advantages of the cloud is that any technical debt you have that is costing you performance. When you're on-prem, it was very easy to say, just go out and buy another, 100 gigs of RAM, buy more cores, license it, throw it in there, whatever. But when you're in on-prem, that costs significant. You can actually put a dollar value to, like, listen, if you let me rewrite this subsystem or spend 3 weeks tuning these queries, I can prevent us from having to scale our machine up, our managed instance up. In my environment, it's all about how much memory can I get. And managed instances, you get memory per allocated core, which is what you pay for. So I think I get 5 gigs of RAM per CPU core that I request. And you have to request them in the buckets that they give you. So I think you go like 4, 8, and then you have to scale up per core. It's not much, but which is why I have a 40-core managed instance with 200 plus gigs of RAM. You can get more gigs per core if you're on more advanced, if you're willing to pay for the next performance tier. So if you're on business critical, I think you get 7 gigs per core instead, which can be quite significant, especially since I'm at 40 cores now, and the next core jump for me is 64. I can't add just like, I just need 8 more cores worth of RAM. Just give me 40 gigs more worth of RAM. I can't do that. So of RAM, yeah, which you can't get in managed instances. You just can't get. Yeah. Vendor products. Yeah. Yeah. So that's
why my vendor product is probably not in the market.
Yeah.
But that's just, I mean, you get a virtual machine instead of any configuration on that side, right?
There's still upper cap limit. So I don't know what the virtual machine limitations on CPU and memory is. I bet it's better than what you get out of managed instances. But if we get to the point where like I need more RAM, I don't need 40 cores of CPU for this workload. I'm consistently running around 30% load, but I desperately need all 200 gigs of RAM for my 1 terabyte database. And it's gotten better. This is a real life what my PLE looked like when we migrated. Is this climb and then drop to 0 as it flushes everything, and then climb and then drop to 0, and that's like 5 minutes. My PLE was terrible. It has gotten significantly better since I was able to rewrite some of these queries and processes that we were using, because I was able to go to them and say, listen, if you want to keep growing the business and you don't want to spend more on these managed instances, you've got to give me the time, you've got to give the resources to rewrite this stuff to be more efficient. And so that's what we did. So managed instances and storage performance. This is another part that bit us hard when we got there, because the one thing you can't test when you're doing this is a real live load. We don't know what that load is going to look like or do to the system. So managed instances, especially their I/O performance, is controlled by how big your database is. So if you have a database that's 128 gigs, then you're going to get a 128 gigabyte SSD to store that database on. And you're going to get performance according to how big that SSD is. So if you want more or need, as in my case, more performance, more I/O for your database, you need to grow it. I have a 3 terabyte database now, still about a terabyte of data that's in there, but I had to grow the databases. I needed that much I/O. I needed far more I/O than a 1 terabyte disk was giving me. And I have a query for this as well. I'll show you with a link to and in the references section is the article I found where it talks about this very specific issue. So you need to grow your disk, your file size in your database so that you can get proper I/O performance for your storage. So it's something that if you're moving to managed instances, you're going to want to make sure you check this out and grow your log files responsibly. We're getting into the weeds, some random stuff now. I use the Azure portal daily. You can mark your favorites for the specific pieces that you use, like SQL DB, managed instances, Key Vault. So they go filter to the top of the list when you're in Azure. Dark mode, if you're one of those people. Who is active works with managed instances. So does Brent Ozar's kit, first responders kit. If you want to use who is active in SQL DB, you'll need to install it in every database. There's no accessible master database to get it into. So you'll have to install it in every user database if you want to use the who is active queries to find what's running. So this is about 4 months after we were in the cloud, and one of the day I came in and users were complaining the database was slow. They always complain it's slow. Well, I knew it wasn't disk I/O because we had solved that, within the first couple of weeks of being in there, and eventually it came down. I found that it was the node, the managed instance node we were running on was restarting every 5 or 10 minutes. It would just restart, and again and again and again. Eventually, we failed over to the other side. At this point, we decided to institute a failover. So that solved the issue. And they said that after they investigated, they said that the managed instance got stuck in a weird state where it was rebooting. It was trying to install an update and just rebooting over and over and over and over and over. They didn't catch it. I would have assumed, but no, we caught it, failed over, and then we complained to them. This was an issue for us. Another issue that we had a lot when we were on-prem was with our full text indexes. These problems mostly went away when we moved to the cloud. But I really miss being able to go to the operating system and kick the full text daemon in the teeth and make it restart. Can't do that here. There's no way to restart, to forcefully restart that full text daemon. Unfortunately, I could not find that undocumented command. It's in our support queue somewhere. It's a command that you can issue that will restart the node. It will fail over the node. So remember that central node I was talking about? It's really like 3 machines under the hood, and ready to fail over internally. It's a redundancy inside the data center. You can basically kick it, and it'll fail over inside the same data center. And it'll come up in a different compute node, but that will invoke a restart of all of the services. So that's the only way we found to, when our full text daemon is just being too obstinate, of kicking it in the teeth, is to, without doing a failover to a different data center. Fortunately, it is, like I said, not nearly as common. There is a bug with full text indexes that they apparently have not fixed, and the way to fix it is to disable RCSI and then turn RCSI back on, and that will resume, if all else fails, full text indexing. So hooray for full text indexing. That was fun. Are there any questions? Would I do it again? Yes, I would do it again. Given, and it's hard to quantify this exactly, because when we were on-prem, I was supporting an even older legacy application there. This migration to the cloud also corresponded with my company forking. It was splitting. They sold off that part of the business, and that ancient piece of software went away from at least my end. I went with the new stuff and into the cloud. And it's hard to quantify system down calls, right? Out of hours calls, which is the only thing I really concerned about. But overall, my calls in the middle of the night, late at night, early morning have gone way down to almost nothing. So I would do it again.
Sorry,
No, that's all right.
I have a couple questions.
Yes, we are using transparent data encryption, and we're using the Microsoft key managed approach. So Microsoft is managing the keys and the key rotation for us.
So we have proper backup into the cloud and restore them.
We only do backups in the cloud because all of our environment is in the cloud. So that's the one thing I forgot to mention about managed instances, is that I think it's being resolved. I think soon you'll be able to restore from a managed instance into an on-prem SQL Server, but it's one way. You can only go to the cloud, and there's no way to get a backup out that you can restore anywhere. So even if I took a backup to a storage account, which again I can't do anymore because I'm on TDE, I couldn't restore it anywhere. There's no on-prem version of SQL Server that would understand the backup and run it. So you're stuck. Once you're there, once you have any data in there, you're like, well, the only way out is to do some wild data extraction. And yeah.
My last question: would you take any costs more?
So running the managed instance, I think, is somewhere around $1,500 per month in compute costs. That doesn't include the storage. That is just the managed instance, and we have to double that because we have a failover group. So that's $3,000 roughly per month. Now that is the public price. I think we pay less than that because we're on a GA license. But that just gives you some idea of what that costs. Could I take $36,000 a year's worth of those 2 machines and build a kick-ass couple of servers and data center with availability groups and license it? Absolutely, I could. But I mentioned that the business really likes having that because that's a capital expense rather than an appreciable expense. The hardware would be appreciable. They like having it as a capital expense. They like paying that money. They also really like, and we really like this part too, is that when something does go wrong, like the software reboot where it got updated, we get to yell at Microsoft and tell them, why did your stuff break on us like this? There's trade-offs. There's a lot of trade-offs, and you have to decide, and the business really has to decide where they're comfortable. And the business chose capital expenses, and keeping Microsoft in charge of hardware was, so they didn't want to be in the hardware business anymore. So,
You haven't hit any you haven't hit any issue. The vendor stall out where you're just down and out, and despite the fact that you yell at somebody, you also can't just emergency mode your way into working it and having a functional environment either.
So we did.
Well, you could, in some senses.
We could.
Or back up to some other.
Yeah, you can't take your kit and go home because you can't get out of managed instances without a lot of effort for that. We did have an issue where we were trying to fail over from one node to another. We were having some type of issue. And when I say issue, sometimes these are issues not with the database, but with the service fabric nodes. So there's something wrong with them, like runaway CPU, memory leaks, lots of issues. And lots of reasons we would do a failover, not just the database. But one of them, I didn't do the check ahead of time to make sure that, because they were always close enough in LSN where it would just, you hit want to fail over, and it would just go over and do it. It would do the last couple of catch-ups on the availability group and then fail over. We were behind. It was they had taken a log backup or just slowed down, network issue. We don't know. We were behind. And so when they hit to do the failover, you have a choice. You can force a failover, or you could do the gradual controlled, right? Which is always choose the gradual controlled failover. And it just sat there for an hour. And now the database is not available for anybody for that hour while we wait. And you can't go back and say, I really want to just get over there. Well, I'll take the data loss now. Let me force it. They won't let you do that. Yeah. So before we do that, as part of the policy now, before we do that, we run the query to check health. How have we drifted the two nodes? Or are they close? And like I said, they're always close now. I've never caught them not being close, except that one time when we tried to do that because we're having some sort of issue. And maybe there was something in Azure that was causing the issue. Some either slowness in storage, which is what really drives, I think, this failover group. Again, they're not talking about it, but I think it's storage copy really is what it's doing, a block copy between, node A and node B for this failover group. So it's not true availability group where you're sending actual log LSNs over, you're sending, blocks over. So it could have been something like that. But again, I mean, but otherwise, no, we've never, other than that one issue, we were never really hit the point where we were like, I really wish we could restore this. Our developers would like to be able to restore whenever they wanted a fresh copy of production, but we're limited with what. And it was like, that was when we turned TDE on, I knew that was coming, and I warned them that for one, I'm not going to be able to restore into this dev environment anymore. That's gone. And I can only do T20, the UAT environment when the stars align, and if they're not aligned, then it's just not happening. So.
That's a common thing is that move from a higher level down. Really, they should have use cases for developers.
Oh, they.
Yeah, but we're critical to take it production and move it back to a right environment, and stress testing environment. That's a TDE.
It stopped us from doing that. And then also we have now a scrubbing process that we run that I developed, of course. I think we're helped by the fact that we don't have to adhere to HIPAA. We aim for HIPAA, but we were not mandated to adhere to it. So we're good away with some things.
What was the old CRM system? Microsoft Dynamics CRM?
I think it was Dynamics. I never saw front end. I never see front ends for these apps. Although I have seen for our flagship, I've seen what it looks like. But yeah.
That's morphed into the Power Platform. Microsoft.
I think it was just
Right.
Dynamics is new. What are you talking
yeah,
about?
Great Plains. It was one of those things. It was one of those things, right? So they had this CRM, this system sitting around, and they were like, we want to get rid of this, and so they stopped paying support, which means they stopped getting updates. They stopped investing in anything into it, and then the project to get off of it stalls, lingers. The new thing doesn't quite handle all the use cases, so they're still using it for this one use case. And then 10 years later, you're trying to drag this thing into the cloud, and it's freaking out because it doesn't understand where it lives anymore. There were 5 people on the data team that were involved. Different aspects of it. I was, for the most part, they took all the regular support stuff, and I did this, and I've dragged them in as I needed help. And then there was a team of the systems side where they would build up all the infrastructure that was needed, and of course that's all scripted out now, so we could hit a button and spawn a new environment that we needed. And then there was the developers, of course. There's probably 3 or 4 developers focused on it. We don't typically keep more than a couple dozen developers on hand. We usually outsource a lot of our development efforts. That flagship app is custom. It's not anything you buy off the shelf. It's something we built or had built for us. So we would maintain it. So we own everything about it.
Having trouble like with the support people trying to figure it out. One thing that drives me up the wall is you can't create a user on an Azure SQL database through the management video.
No, you have to do it through code. You have to do it through T-SQL to create that.
That creates me a lot. So we don't have any DBAs now, so our systems team has to pick it up, and if they can't,
Yeah.
click on a GUI.
Yeah. Give them a PowerShell script that writes T-SQL. No, as far as that goes, we are not using integrated authentication for the database access. We're using usernames and passwords. I control all of that, or we control all of that. So we'll create the accounts for them. For the most part, the development environment, we don't really monitor let them run wild down there. They can do what they want. We help them out as they need it. Production, they have a login, a restricted login that they can use if they need to, and they share it amongst themselves. You can read only into the database if they do need raw T-SQL access. But for the most part, they don't. They use their application logs, and that's how they do their testing and stuff.
Thinking back in my head for your environment problem, we use data factory to move some stuff around.
Yeah, you probably could. But again, I mean, it depends on the size of your data.
Data factory is also not cheap.
No.
And you have the database servers nice and I guess pure in a sense that you didn't have any side application to be on that same server. You're laughing because you
I managed that. I developed one of those like that. Where I managed a system where it was shared like that. Yeah, database and the application running on the same machine. Nope, we had always stayed away from CLRs. The thought there was that even though I think it would have been useful in a couple of cases, that SQL is the most expensive application you're going to own, and why steal processing cycles from your most expensive server? So If you need a CLR, then no, you don't. Make the app do it, or or write something that'll read and then write back to it. But no, we weren't hit with that. This at least the stuff that we moved to the cloud was mostly pure. It was a SQL Server, and that's all it ran. We had another server running reporting services and its own little SQL Server, to run reporting services, and integration services, and those stuff just went up to the cloud fairly easily. But we didn't have that shared. But yeah, managed instance, we really lucked out. We fit within the feature set. We weren't using anything that it couldn't handle anymore. And it's nice having the latest version of SQL Server at all times, using the greatest and the least clauses and string ag and all those fun features where people were like, oh, I really wish I could have that. Oh, I do. I have them all.
I'm sorry, you changed your feature number at the same time as doing this?
We went from SQL 2016 to, so 3 years ago, I think it was the equivalent of 19 or 2020, SQL 2020. So like, no, we kept it at 16. Okay. We have since migrated. Okay. Yeah, we kept our compatibility. But so I think the only thing that was compatibility level locked, I think at the time, was OpenJSON. I think that's the only one that I know of that was compatibility locked, or maybe it was string ag. Because I had a system I wrote that I had to dive into the master database to do that particular function, to get that bit string aggregation or JSON cracking done. As I just went up to the master database for that system and then back down. It's fun workarounds, workarounds for everything. But yeah, no, we kept our compatibility level at 2016, and now I think we're at 2020. And we'll probably just stay there for a while, cruise there, because all the features they're adding I don't think are compatibility level locked at this point.
Are you running any traditional ISVM?
Just reporting services and integration services at this point. Those are the two machines that are still kicking as a VM. It was SQL Server on VM, and that's just because they don't have paginated reports, and a lot of our stuff really needs pages. We email these to our clients, to our vendors, some of these reports out. So we really need to be able to render it into a PDF or an Excel doc. We just can't do that with Power BI. How they want to run it.
I've got a few of this, mostly because vendors will support not running on a traditional database.
And then we're still using integration services because they've not decided to spend the money to migrate everything up to the Data Factory. So we're still using IS.
Our data team is looking to use Fite instead of Data Factory now, but it doesn't seem to be that.
Oh man, but integration services is one of those things that only exists because there's nothing better in town.
Really costs money to, it's like
Yeah. Unfortunately, most of our transformations is a pure, like, read this flat file, dump it into a table, and then run these transform stored procedures on top. So our transforms are pretty simple.
We're actually pulling out of a DB2 database and dumping into Lakehouse.
Okay.
Also why we couldn't afford to get in the cloud, because we're paying SharePoint to host the AS400.
Yeah. Were there any questions on Teams that I may have missed? There we go.
I also, sorry, I was remiss in thanking Lori for the wonderful meeting space and the lunches. Perfect as always. Want to say something?
I have nothing really to add other than apologize for the air conditioning.
So we thank Doherty for the wonderful meeting space and the lunch. And for those of you online who are in the St. Louis area, please consider coming to our December meeting or any of the meetings in the future on-prem. I mean, we really appreciate seeing you and getting a chance to network and know what's going on in the St. Louis area. Wanted to thank Jonathan. Here's the resources that he's listing. And whoops, Neil is typing something in the chat. But India just said, thank you, very insightful.
Thank you very much.
And we look forward to having the December meeting, and wanted to thank everybody again for coming to this event. And it was being recorded, so I'll work on getting that uploaded to our YouTube channel.